Some higher members of aliphatic carboxylic acids, known as fatty acids, occur in natural fats as esters of glycerol. Carboxylic carbon is numbered 1. If more than one carboxyl groups are present, then the ending E of the alkane is retained. Grignard reagent react with carbon dioxide to form salts of carboxylic acid, which in turn give corresponding carboxylic acid after acidification with mineral acid. Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry. So today I am back with session 6 of the chapter Aldehydes, Ketones and Carboxylic acid. So in the last session we discussed the various chemical reactions of aldehydes and ketones, right? So in today's session we are going to start with carboxylic acids. We are going to see the nomenclature, the structure of what is carboxyl group also we'll discuss, and the various methods of preparation of carboxylic acid. So beginning with the introduction to carboxylic acid, okay, the general representation is RC double bond OH. So this is also a carbonyl compound itself because it is having this C double bond group, right? So the carbon compounds containing a carboxyl functional group, that is COOH, are called carboxyl acids. The carboxyl groups consist of a carbonyl group attached to a hydroxyl group. So this part is called as a carbonyl group, right? This much part, that is carbonyl group with the hydroxyl group, is called as a carboxyl group. What it is called? It is called as a carboxyl group. Okay, so the carboxyl group consists of the carbonyl group and the hydroxyl group. So this carboxyl group containing compounds are called as carboxylic acids. So some higher members of aliphatic carboxylic acids, known as fatty acids, occur in natural fats as esters of glycerol. Okay, moving on to the nomenclature. So nomenclature, the basis of IUPAC nomenclature already you have studied. Here what you have to remember is what is the suffix that you have to use. Okay, so the hydrocarbon part, whatever the name is, that E you have to change it with oic acid. It has to be changed with oic acid. In case of aldehyde it is al, ketone is its own, and in the case of carboxylic acid it is oic acid, right? So by replacing the ending E in the name of the corresponding alkane with oic acid. Carboxylic carbon is numbered 1. If more than one carboxyl groups are present, then the ending E of the alkane is retained. That means more than one carboxylic group is present, then whatever the alkane name, that should be written, and then we have to write dioic or trioic acid, like that. Clear? Now the next one is the number of carboxyl group is indicated by the prefix di, tri, etc. to the term oic acid. So while we are going to discuss few examples, you will be clear with that. So the first one is HCOOH. That's the first carboxylic acid and the simplest one, which is having only one carbon atom. So one carbon atom means which will be the alkane? It will be methane. So that E in methane has to be replaced by oic acid. So the IUPAC name will be methanoic acid. The common name is formic acid, which comes from the name formica, that is obtained from the red ant. That is the acid which is present in red ant. The Latin name for ant is formica. Red ant is formica. From that you are getting the name formic acid. The next one is CH3COOH, two carbon atoms. So it is ethane. Okay. So ethanoic acid. Ethanoic acid will be the IUPAC name. Acetic acid is the common name. So you might have heard acetic acid, which is present in vinegar, right? So which is the acid? It is ethanoic acid. Next one is CH3CH2COOH, three carbon atoms. So it is propanoic acid, and the common name is propionic acid. The next one is CH3CH2CH2COOH, four carbon atoms. Of course it is butanoic acid, and it is called as butyric acid in the common name. The next one you can see CH3 twice CHCOOH. What does that mean? CH3 you have, then CHCOOH you are having. To the second carbon atom itself you have another CH3. So how do you number it? The carboxyl group containing carbon atom should get the first priority, right? So it is 1, 2, 3. So on the second carbon atom you have the methyl group, and the principal chain is 3 carbon atoms containing. So it is going to be 2-methyl and propanoic acid, right? 2-methyl propanoic acid. Clear? Next one is HCOH, that is COOH. Okay, so you have two carboxylic group here. So the common name is oxalic acid, and the IUPAC name ethane dioic acid. So here you don't have to replace that E. That full name of the alkane should be written. It is ethane, two carbon atoms, right? Ethane dioic acid, because two carboxyl groups are there. Next one is COOH, CH2COOH. Here also you have two carboxylic groups, and you have a total of 3 carbon atoms. So this is going to be prop, and it is propane. We'll write propane itself because there is more than one carboxyl group, and we are going to add the dioic acid. Clear? Propane dioic acid, because see, one functional group, another functional group. So dioic acid, and it is called as malonic acid, common name. Now COOH, CH2 twice COOH. So what is that actually? You have COOH, then you have one CH2, one more CH2, and then you have COOH. So totally 4 carbon atoms are there, and you have 2 carboxylic acids also. So this is of course butane dioic acid, right? Butane, 4 carbon atoms, dioic acid, because 2 functional groups are there. It is called as succinic acid. The next one is COOH, CH2 thrice COOH. So here also it is dioic acid itself. Total number of carbon atoms, 3 here and 2 from here, so 5. So it will be pentane dioic acid. So when more than one functional group is present, that is more than one carboxyl group is present, don't forget to write the full name of the alkene there. The common name is glutaric acid. Moving on to the next one, COOH, CH2 4 times COOH. This is also dioic acid itself. So total you have 4, 5, 6 carbon atoms. So this is hexane dioic acid, which is called as adipic acid in the common name. The next one is COOH, CH2, CHCOOH, CH2 COOH. So here you can see CH2 COOH is there, and on the second carbon atom you have another COOH, and on the third carbon atom you have another COOH. So this much part can be considered as your principal chain, that is the propane, and on the first carbon atom you have one functional group, second carbon atom you have one carboxyl group, third carbon atom you have one carboxyl group. So what will be in the name? It will be propane. See, 1, 2, 3. So this is 1, 2, 3, 3 carbon atoms propane, and on the first, second and third carbon atom you are having the carboxyl group. So it is propane 1, 2, 3 tricarboxylic acid you can write, or trioic acid also you can write. Moving on to the next one, on benzene you have the COOH. So this is called as benzoic acid, or else you can also see benzene carboxylic acid, or else benzoic acid. Benzoic acid, it's the common name as well. Next one is, on benzene you have CH2COOH. Now what is the name for this? This is called as 2-phenyl ethanoic acid. Now why it is called as 2-phenyl ethanoic acid? This is the first carbon atom, this is the second carbon atom, because the functional group will get the highest priority. So on the second carbon atom you are having a benzene ring. So if benzene is present as a substituent, it is called as phenyl. So on the second carbon atom you have phenyl, so it is 2-phenyl. So 2 carbon atoms are there in the principal chain, so the word root is eth, so it will be ethanoic acid. The next one is, on benzene you have COOH, again it is a dioic acid. It is called as phthalic acid, and it is benzene 1, 2 dicarboxylic acid. On the first and second carbon atom you are having. Clear? Now moving on to the structure of carboxyl group. Carboxyl carbon is less electrophilic than carbonyl carbon because of resonance. So carbonyl carbon, it is just this one, right? So for example, I have taken aldehyde. So here, because of the more electronegative nature of oxygen, this will be a polar bond where oxygen will have a partial negative charge, carbon will have a partial positive charge. But in this case, you have another bond also, another hydroxyl group is also present. So what is happening here? This is RCOOH, right? So here what is happening, because of this double bond, there is a polarity difference here because of the electronegativity difference. So this electrons will be attracted towards oxygen, oxygen will get a negative charge. Now what happens? There can be resonance which is also taking place. How? Because there is lone pairs of electrons which is present in the oxygen in the hydroxyl group. So that can be shifted here and a double bond will be formed here. So again it can be shifted back and it can form a resonance structure. So because of resonance structure, it is going to be more stable and less reactive. Clear? Now, moving on to the different methods of preparation of carboxylic acid. First one is from primary alcohols. So we have already studied this. Using strong oxidizing agent, we can convert primary alcohols to carboxylic acid, right? So primary alcohols are oxidized to carboxylic acid when it is treated with potassium permanganate in neutral acidic or alkaline medium, or potassium dichromate or chromium trioxide. So you can use KMnO4 or K2Cr2O7 or else KrO3. Either of this you can use. So primary alcohol, this is a primary alcohols. CH2OH will be converted into COOH. Okay, CH2OH is converted into COOH. Now the next one is CH3, CH2 8 times CH2OH. So here also only the CH2OH alcohol part will convert into carboxylic acid part. Clear? Now moving on to the next one is from alkyl benzene. Alkyl benzene. Okay, that is on benzene you have an alkyl group which is present. Aromatic carboxylic acids can be prepared by vigorous oxidation of alkyl benzenes with chromic acid, that is CrO3, or acidic or alkaline potassium permanganate KMnO4. The entire side chain is oxidized to the carboxyl group irrespective of the length of the side chain. Primary and secondary alkyl benzene are oxidized in this manner. Tertiary is not affected. So 2 points you have to remember here. That is, if you are taking primary or secondary, you are going to get the product, that is your carboxylic acid. But if you are taking tertiary in this method, you cannot prepare it. Another important point is how much ever length chain you are taking, that is, here you can see this is toluene, that is, it is alkyl benzene. Which alkyl? It is methyl benzene. Here it is 1, 2, 3, 3 carbon atoms, so this is propyl benzene. Okay, so in this cases, both these cases the length of the alkyl chain is different. Here only 1 carbon atom is here, here 3 carbon atoms are there. But still what is going to happen is, after the reaction, the carboxylic acid will be replaced there. You are not going to get any extra products. How much ever length here, if you are taking methyl, propyl, pentyl, butyl, whatever it is, just what is going to happen, COOH will be obtained there. So let's take the first one, that is methyl benzene in presence of KMnO4 or chromium trioxide. What is going to happen? First you will get a potassium salt of the benzoic acid, that is from this KMnO4 you have the K, right? So the sodium salt of the benzoic acid will be formed, to which it undergoes hydrolysis and H will be added here. So what will happen? You will get the H here, that is benzoic acid. Here also we have just changed the alkyl group, that is propyl we have taken, but we are getting the same product. Clear? So that is one important part in this method of preparation. Next one is from nitriles and amides. Nitriles are hydrolyzed to amides and then to acids in the presence of H plus or OH minus as catalyst. So this RCN, RC triple bond N, which is called as nitrile, in the presence of H plus or OH minus, what is going to happen? First it will form amide, that is RCONH2. Amide will be formed, which again further reacts with H plus or OH minus to form carboxylic acid. Okay, so 2 methods we studied from nitrile. First it will form amide, then from amide it will form carboxylic acid. So you can see CH3CONH2, that is ethanamide, directly it reacts with H plus or OH minus to form the ethanoic acid. So the number of carbon atoms will be same. CH3CONH2 will form CH3COOH and this NH2 will combine with hydrogen and form ammonia. Okay, so here you can see benzamide, that is CONH2. Here also you will get COOH here and this NH2 combines with H and form ammonia. So this is the products that you are going to get from nitriles and amides. So from nitriles first you will get amides and from amides you will get the carboxylic acid. Now moving on to the next method from Grignard reagent. Grignard reagent react with carbon dioxide to form salts of carboxylic acid, which in turn give corresponding carboxylic acid after acidification with mineral acid. So you have RMGX, it is Grignard's reagent, reacts with dry ice, CO2, okay, carbon dioxide in presence of dry ether. What is going to happen? You are going to get, see, RCO is already present. Okay, so what is going to happen here? The alkyl part is going to get attached to the carbon and the MgX part is going to get attached to the oxygen. So what is happening here? You have the RCO. RCO part is here, that is R, C and O will be there, and to this oxygen atom MgX will be attached, which is shown here, O minus MgX plus. Now it is going to hydrolyze in presence of any mineral acid, H plus, okay, any mineral acid which is able to donate its H plus. So what is going to happen here? You will get an OH here, RCOOH. What it is going to be? That is, you are going to get the corresponding carboxylic acid and you will have MgOHX. H will be added here, MgOHX will be formed. Clear? So now moving on to another example, CH3MgBr and in presence of CO2, dry ether, what is going to happen? This CH3 will attach to the carbon, OMgX. That is, the MgBr will attach to the O. So what you are having, CH3CO and OMgBr will be there, to which we are going to hydrolyze it. So you will get the OH here and the H here. So what you will have, CH3COOH, which is acetic acid, and MgOHBr will be found. Clear? Now the next method is from acyl halide. Acyl halide we already know, acid halide. Okay, that is RCOCl, obtained from carboxylic acid itself. So acid chlorides, when hydrolyzed with water, give carboxylic acid, or more readily hydrolyzed with aqueous base to give carboxylate ions, which on acidification gives carboxylic acid. So acyl chloride, that is RCOCl, reacts with water, hydrolyze and form carboxylic acid. Okay, that is the Cl will be replaced by OH from the water. So you will get the corresponding carboxylic acid and Cl minus will be removed. Right. Now another one is it can react with the base also, that is OH minus. It can react with the OH minus also, and what will be formed? Carboxylate ion will be formed first, and then we are going to acidify it and H plus will be added, and to this H plus will be added, you will get the carboxylic acid. So in either way you can do, you can add water directly, you will get carboxylic acid, or else you can add a base by which you will get carboxylate ion, from which by the addition of H plus you will get the carboxylic acid. Next one is from acyl anhydride. Now what is an acid anhydride? RCO and RCO. This is called as an acetic anhydride or acid anhydride, right? Anhydrides are hydrolyzed to corresponding acids with water. So we have taken benzoic anhydride here. So the R here is C6H5. Okay. So C6H5CO twice O. So that you can see here. Hydrolyzing, what you are going to get, which is the alkyl you have taken here or aryl group. Based on that you are getting the carboxylic acid. So C6H5CO it is. So C6H5COOH will be formed. Okay. So that is benzoic acid will be formed. Here we are taking the same example. So the next example, benzoic anhydride, we have taken CH3COO-COCH3. Okay, so here it undergoes hydrolysis and forms two products, benzoic acid as well as ethanoic acid, because in this part you can form an ethanoic acid, this part you can form a benzoic acid. Clear? Next one is from esters. Acidic hydrolysis of esters gives directly carboxylic acid, while basic hydrolysis gives carboxylates, which on acidification gives carboxylic acid. So we have taken ester here, that you can see COO, that is C double bond O C2H5. Right. So ester is taken here. It undergoes hydrolysis. What you are going to get? Carboxylic acid. So this is in acidic medium. Directly this part, that is COOH you will get here. C2H5OH you will get. You will get the alcohol. That is, this bond is going to break. In this side hydrogen will be added. In this side hydroxyl group will be added. So you will get ethanol and the carboxylic acid, which is benzoic acid. Now let's see here. CH3, CH2, CH2, COO, C2H5. In presence of basic medium, what is going to happen? First you will get the salt, which is the sodium salt. So here you have taken sodium hydroxide, which is the base. So what is going to happen? This bond is going to break. Na will be added here and OH will be added here. So you will get ethanol and the sodium salt of the carboxylic acid, which is formed, which on addition of H plus, that is acidification, what is going to happen? This Na will be removed, H will be added here. CH3, CH2, CH2, COOH will be formed, that is butanoic acid. So in the next session, we are going to discuss the physical and chemical properties of carboxylic acid. So I hope the concepts that I've covered in this session is clear for you. So that's all for today. Thank you.